Alright, so we're going to work some more on this video, or this target here. Example 5, finding the normal line. Write an equation for the normal line to the curve f of x equals 4 minus x squared at x equals 2. I would suggest you find the tangent line first. Pause the video, give it a try, and then unpause the video to check your work. Alright, so what we'll do is we'll start by finding the point. Okay, so what is f of 1? If we plug 1 in, f of 1 would be 4 minus 1 squared. F of 1 is 3, so that gives us the point 1, 3. And then we'll find the slope. And our slope we get by finding the limit as x approaches 1. Of f of 1, which is, or f of x, which is 4, minus x squared, minus f of 1, which is 3, all over x minus 1. I will clean that up a little bit. We got the limit as x approaches 1. 4 minus 3 is 1. Minus x squared over x minus 1. We do our plug and chug, and yep, we get 0 over 0. Like we said, that's a good thing, so we're going to do some more work. We'll factor and cancel. Limit as x approaches 1. The top is the difference of squares, so we got 1 minus x, 1 plus x, all over x minus 1. We can see it cancels, but not exactly. We're going to need a negative in place of it. Now if I do my plug and chug, I get 1 plus 1 is 2, and then I negate it. So my slope of my tangent line is negative 2. So my tangent line would be y minus 3 equals negative 2 times x minus 1. And then my normal line will be the same thing, except I flip and negate my slope. My normal line is y minus 3 equals 1/2 times x minus 1. All right? Our next slide, speed, this shouldn't say speed. That is technically velocity. If you're in physics, you know the difference between speed and velocity. That's very important. It's just saying that, if we take the instantaneous rate of change of position, we get instantaneous velocity. So the instantaneous rate of change of position is velocity. So here for this one, our function is 2t squared minus 1. Find this, which you should recognize as the instantaneous rate of change at t equals 2. Pause it and try it. So when we do this, t equals 2 will have the limit as h approaches 0 of f of 2 plus h minus f of 2 over h equals the limit as h approaches 0. Let's plug 2 plus h in, so we got 2 times 2 plus h squared minus 1 minus f of 2 would be 2 times 2 squared minus 1 all over h. Now you can go ahead and try it, do your plug and chug, but it will work out to 0. So we'll clean this up a little bit. Before trying factoring and canceling, you should always try a little cleanup. So we got the limit as h approaches 0. Excuse me. 2 times, I'm going to square 2 plus h. I get 4 plus 4h plus h squared minus 1 minus 2 times 2 squared is 4 times 2 is 8 minus 1 is 7 all over h equals the limit as h approaches 0. Let's distribute that 2 there. We got 8 plus 8h plus 2h squared minus 8, combine like terms at the end, over h. These cancel. There's an h in common in the numerator, so we can factor that out. So we got h times 8 plus 2h over h. The h's cancel. We're left with 8 plus 2h. Let h approach 0, we get 8. So what this is saying is at t equals 2, so at 2 seconds, the velocity of the position is 8. Do they give units? Feet per second. Alright, so if this is a position function at 2 seconds, the velocity is 8 feet per second using the limit of our difference quotient. Alright, so find the slope of the graph at the point 2, 1. Now on its surface, this should be a ridiculously easy problem because this is a linear line. Right, what I want to show you is how it works out to be a slope of 2. If you're asked this question on a test, I would 100% expect you to say the answer right away. But I'm going to illustrate how we get our answer using the calculus. So you got an example where it works out nicely and you can see it ahead of time. Alright, so we're going to find the slope of the graph of f of x equals 2x minus 3 at the point 2, 1 using our difference quotient. So we want to have the limit as x approaches 2 of f of x, which is 2x minus 3, minus f of 2, which is 2 times 2, 4 minus 3 is 1, over x minus 2. We'll clean that up. We got the limit as x approaches 2 of 2x minus 4 over x minus 2. Plug and chug, you get 0 over 0, so we'll factor. Factor 2 out the top, that's 2 times x minus 2 over x minus 2. The x minus 2's cancel, and we're left with 2. So the slope of the graph of 2x minus 3 is 2. And again, you should have known that just from basic algebra. But here is the calculus that supports that. Okay, try this one, pause, and come back to it. Find the slope of the tangent line to the graph of f of x equals x squared at the points 0, 1, and negative 1, 2. All right? So at x equals 0, we'll break this into 2 separate slides. We'll do each one. At x equals 0. So we'll take the limit as x approaches 0. We'll find f of x is x squared plus 1 minus f of 0. 0 plus 1 is 1 over x minus 0. Clean this up. We get the limit as x approaches 0 of x squared over x. Well, those cancel to x. And when you plug and chug, you get 0. So the slope of the tangent line to x squared plus 1 at x equals 0 is 0. And if you look at a graph of it, you should know what x squared plus 1 looks like. You can see it bottoms out there. Has a slope of 0. Alright, try in the next one. We'll do it in maroon. So we'll do at x equals -1 now. So we'll take the limit as x approaches -1 of f of x, which is x squared minus 1, plus 1, sorry, minus f of -1, you got -1 squared plus 1 is 2, over x minus -1 becomes x plus 1. Clean that up a little bit. We got a limit as x approaches -1 of x squared minus 1 over x plus 1. Alright, plug and chug, we get 0 over 0. So we got more work to do. The top is a difference of squares, so we can factor that. The bottom is x plus 1, and we can cancel. Plug and chug, we got -1 minus 1 is -2. So the slope at x squared plus of x squared plus 1 at x equals -1, the slope of the tangent line is -2. Alright, so in conclusion, our average rate of change is our slope of our secant line, and that is, if we have 2 points, it's f of A minus f of B, or vice versa, over A minus B. Our instantaneous rate of change, that'll be the slope of the tangent line, and that will be the same idea, except we're having A approach B. We generally write this as the limit as x approaches A of f of x minus f of B, or A, sorry, since my variable I'm using is A, f of x minus f of A over x minus A.